Hello class, and welcome to today's algebra lesson, which is about solving quadratics by square roots and factoring. By the end of today's lesson, you will be able to use these two algebraic techniques to solve quadratic equations. So we're going to start with the square roots. What that means is that if I have a value squared, I can solve it by taking the square root of both sides of my problem. The square and square root cancel out. So that means the left side is just going to be x plus 5. When I take the square root of 21, you would plug that into your calculator, and that is going to give you a long non-repeating decimal. For our purposes, we are always going to round to two decimal places. So the number is 4.582. Meaning that it is going to round to just 4.58. We also have a second option. Positive times a positive gives you a positive, or a negative times a negative gives you a positive. So every square root has a positive factor and a negative factor. Then we're back to simple algebraic equations that we can solve, both of which in this case are going to be solved by subtracting 5 on both sides of your equation. And we end up then with our first answer is x is equal to negative 0.42. And our second answer is going to be x is equal to negative 9.58. So we have these two options when we solve by square roots. Go ahead and try this one on your own. So square rooting both sides is going to get rid of the squared, and then we take the square root, which is either going to give us a positive 8.77 after rounding or a negative 8.77 after rounding, meaning your two answers are going to end up being 26.77 or 9.23. So with the square roots, we are simply square rooting both sides and then continuing to solve. The other thing that we can do is use our principles of factoring. When we use our principles of factoring, we are applying what we call the zero product property. That means for any two real numbers, a and b, if those values are being multiplied and equals 0, then either a or b equals 0. Remember, what we are truly trying to solve here is a quadratic function and where it crosses the x-axis, aka where it equals 0. So this basically says that your factors must come out to equal 0. So what does that mean for us? We have many different factoring techniques that we looked at in our last chapter. I'm going to run through examples of each of them. The first one is going to be factoring by GCF, so taking out what they have in common. We look at our two factors here, and we notice they both can be divided by 4, and they also both have an x. So their GCF is 4x. 4 divided by 4 is 1. X squared, take out an x, is just x. If you wrote 1x there, that is also acceptable. Minus 12 divided by 4 is going to give you 3. X take out an x gives you nothing left, and we need that set equal to 0. This is where our zero product property becomes part of our process. I take my first factor, which in this case is 4x, and set that equal to 0, and then I take my second factor, which in this case is x minus 3, and also set that equal to 0. Then I need to go ahead and solve both problems. The first one is solved by dividing by 4, so I get an answer of x is equal to 0. The second one is solved by adding 3 to both sides, and I get an answer of x is equal to 3. So this graph would have two places where it crosses the x-axis. You can always double check your answers by plugging it back into the calculator. You could plug the first one in and do 4 times 0 squared minus 12 times 0, and that is in fact going to give you 0. You could plug in the second answer and do 4 times 3 squared. 3 squared is 9, times 4 is 36, minus 12 times 3, which is also 36. 36 minus 36 equals 0. So you can plug your answers back into the calculator to check them. You aren't required to do that, but just know you can always check your answers. Go ahead and try this one on your own. In this case, your GCF is 7x and your leftovers are x plus 7. Solving each part, you're going to find that x equals 0 and x equals negative 7. On our next piece here, when you are solving, we need it to equal 0. Right now, our equation equals negative 20. So I'm going to add 20 to both sides. 20 is not a like term with either of my two factors. So I've got x squared plus 9x plus 20 is now equal to 0. There is no greatest common factor here. We can take the square root of x squared, but we cannot take the square root of 20. So that's going to now bring us back to our box. 1 times 20 is 20. So my factors are 1 and 20, 2 and 10, and 4 and 5. I need the factor that can add up to 9. So that's going to be 4 plus 5. Putting that into my box now, I've got my top left is x squared. My bottom right is 20. My first factor is 4x. Second factor is 5x. The piece that x squared and 4x have in common is just an x. So the side is going to be x times x to get x squared. 4 times x to get 4x. X times 5 to get 5x, and 4 times 5 is 20. So my two factors are x plus 5 and x plus 4, and we want that to equal 0. So that means one of our two pieces has to equal 0, so we're going to separate it out, and we're going to say our options are x plus 5 equals 0, or x plus 4 is equal to 0. Solving the first one, I'm going to find out that my answer is negative 5, not positive 5. X is equal to negative 5. And then for my second one, I subtract 4 on both sides and find out that my second possible answer is x is equal to negative 4. Once again, you could plug them back in to prove that they both give you an answer of 0. Go ahead and try this one on your own. We are looking for the numbers that multiply to 64. So I've got 1 and 64, 2 and 32, 4 and 16, 8 and 8. In order to get to a negative 12, I have a positive 4 and a negative 16. If I would have tossed that into the box, we would have had our top left being x squared, bottom right being negative 64, splitting up our factors into negative 16x and a positive 4x, and then pulling those pieces to the outside to get our two factors of x plus 4, x minus 16. So when we solve, we get answers of x is equal to negative 4 and x is equal to positive 16. Next piece, we once again check for a greatest common factor. They don't have one. We can't square root 12, so that's going to put us back into our box. I've got 12 times 3, which gives me 36. So factors are 1 and 36, 2 and 18, 3 and 12, and then 4 and 9. I am trying to get to a negative 13. So in this case, I am going to have 4 and 9 gives me a positive 13. So I go opposites and we go negative 4, and negative 9 is going to give me a negative 13. So now I take that and I put it into my box. Top left is my front term, so 12x squared. Bottom right is my back term, so 3. Negative 13x gets split up into negative 4x and negative 9x. Then we are looking to pull out our greatest common factors. 12 and negative 4 can both be divided by 4. X and x squared can both lose an x. 4 times 3 and x times x is going to get us back to 12x squared. 4 times negative 1 is going to get us back to negative 4x. 3 times negative 3 gets us to 9, and negative 1 times negative 3 does in fact give us a positive 3. So my two factors here are 4x minus 3 and 3x minus 1. Both of those are going to be multiplied to get to 0. So now I need to solve my two pieces. The first one being 4x minus 3 equals 0. The second one being 3x minus 1 is equal to 0. As I solve the first one, I add 3 to both sides, and I get 4x is equal to 3. Dividing by 4, 3 can't be divided by 4, so my answer is a fraction. X is equal to 3/4. When I solve the second one, I add 1 to both sides, and I end up with that 3x equals 1. Dividing by 3, 1 can't be divided by 3, so once again, I end up with a fraction. Answer being x is equal to 1/3. Go ahead and try this one on your own. First step, subtracting 2 from both sides to get it equal to 0. Then I have 7 times 2 is 14. To get to a negative 13, I need a positive 1 and a negative 14. Plugging that into our box and factoring out, I get x minus 2, 7x plus 1. Solving each of those, I get answers of x is equal to 2 and x is equal to negative 1/7. So those were examples with our GCF and then our boxes, and now we have our special case examples. So these are the ones where we can take our square roots. So we look at 49, the square root of 49 is 7. We look at x, the square root of x is, square root of x squared is x. Since there is no middle term, that means I need the negative case times the positive case. Remember, if there is nothing in the middle, we need a positive and a negative to cancel the middle out. So each of those is equal to 0. I now take and separate them out, and I say 7 minus x is equal to 0. And 7 plus x is equal to 0. When I solve the first one, I'm going to subtract 7 on both sides, giving me that negative x is equal to negative 7. Then I have to divide that by a negative 1 on both sides, and I get my first answer of x is equal to 7. With the second one, once again, I'm going to subtract 7 on both sides, and I find out that x is equal to negative 7. Go ahead and try this one on your own. Square root of the front, square root of the back, negative and positive cases. Solving each piece, we find out that our answers are 11 and negative 11. Last type of example here. First thing we've got to do is we do have to get it set equal to 0. So I'm going to subtract 45 on both sides of my equation. And when I do that, I'm going to end up with 25x squared plus 60x plus 36 is equal to 0. Once again, we are in our special cases here. So I'm taking my square root of the front, which is 5x, square root of the back, which is 6. I need to double check off to the side. 5x times 6 is 30x. That is, in fact, half of my answer. So because we have a positive 60x in the middle, that means I have the same answer repeated twice. So 5x plus 6 and 5x plus 6 equals 0. Because it is the same factor twice, that means you only need to solve your problem once. So I've got 5x plus 6 is equal to 0. Subtracting 6 on both sides, I get 5x is equal to negative 6. Dividing by 5 and dividing by 5, negative 6 cannot be divided by 5, so we get an answer of negative 6 over 5. Or if you wanted to convert it into a mixed number, you can say x is equal to negative 1 and 1/5. You can convert your answer to a mixed number if you want to. You do not have to. Go ahead and try this one on your own. Adding 37 to both sides gives us 9x squared minus 48x is equal to 64. We have then our square roots of 3x and 8. Notice in this case, I decided to write it in the squared format, which then brings us back to our square root examples. So we've got 3x minus 8 is equal to 0. Adding 8, dividing by 3, I end up with x is equal to 8/3. Or if you chose to convert it into a mixed number, we have 2 and 2/3. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.